Okay, on Friday, we went over vertical parabolas, and today we want to talk about horizontal, and then we're going to graph 3 of them. Who got to judge me on Friday? Who was that judged me? Allie judged me on Friday. She gave me a score of like a 3 right away. I do want to let you know that last hour I landed a perfect 10, and before that was a 9.8. Before that was like a 7.3, but I'm not going to lie, it was pretty good. Like, we'll see. But well, we're going to give other people a chance to judge me today. So we'll have Jordan can judge the first one. Okay, Jordan? You up for it? Yep. Scared? Nervous? All right. Okay. Well, decide how tough of a grader you want to be. I'll accept whatever you give me. You give me a -5, I'll live with it. Guess I'm a -5. All right. So a horizontal parabola has the equation of x is equal to a times y minus k, quantity squared plus h. That is different from your y is equal to a times x minus h squared plus k. And so if you graph a parabola horizontally, you notice that it can open up to the right or to the left. So that spot right there, we call that the vertex. And the vertex is located at HK still. This is an important part of the problem that you pay attention to. In this situation, the vertex was also HK. Notice the difference. Here, h is on the inside of the squared with the x. Here, the h is on the outside. You see that? Here, k is on the inside with the y. Here, it's on the outside. So please take note of that and just be prepared for that change. The axis symmetry is a horizontal line. It divides the parabola directly in half. The parabola, the axis symmetry, it's a horizontal line. Horizontal lines have an equation of x equals or y equals? Y equals, and it will pass through the k value, y equals k. Remember, you get to put your own set of notes together for this test. No example problems, it's just notes. If you want to clip these out and put them on there, that's fine. Rewrite them however you want. That's up to you. All right. The direction of opening, if A is positive, it opens to the right. And if A is negative, it opens to the left. Whereas in the other situation, we have if A was positive, it opened up, and if A was negative, it opened down. In order to find the others, we needed to determine the p-value, namely that A is equal to 1 over 4p. P is the value that we use to find the focus. The focus sits p units on the inside of the parabola from the vertex. So if I'd like to write an equation for the focus, I move horizontally. If I move horizontally, will that change the h value or the k value? H value. So I'm going to take h and I will add p. You make it? Are you gonna make it? Really? She's in Florida right now. DECA. All right, so the directrix, it's p units on the outside of the vertex, on the outside of the parabola. And so that is a vertical line. Vertical lines have equation of x equals, and it is going to be h minus p. And the length of the lattice rectum is the absolute value of 4p. That does not change. We all good? All right, let's try to sketch these parabolas. We're going to do 3 of them. Jordan gets to be the judge of the first one. So this one right here, 2x equals y squared, we are going to find the direction, the vertex, the axis of symmetry, the focus, the directrix, and the length of the lattice rectum. rectum. All right, you want to decide between you and your partner right now, is this a parabola that opens up, down, right, or left? Take about 30 seconds, talk to your peer, decide up, down, right, or left. Go. Let's check it out. It is going to be an x equals, because the y is being squared. So you know that this is a sideways parabola. And because it's a sideways parabola, horizontal parabola, you're going to solve for x equals. And so it's x equals 1/2 y squared. So this does open up to the right.
Oh, let's go.
And the vertex is located at 0, 0. There's no adding or subtracting that's happening on the inside. So I'm going to plot 0, 0. I'm going to make a 3x3 graph. Took the dog for a walk last night. Dog's name is Talia. She's a boxer. I want to name her Piper, but the kids won out, so she's kind of a little monster. All right, so I plot that. The axis of symmetry, is it going to be horizontal or vertical? Horizontal. It's going to go the direction of the opening. It's okay, Sophie, you're super tired. The equation for a horizontal line is the equation in x equals or y equals? Y is equal to 0. So those should be pretty straightforward. The next three, we have to find what value? P. So P, we say that A, or 1/2, is equal to 1/4P. So we cross multiply, we get 4P is equal to 2. Divide by 4, P is 1/2.
So where are we getting this little 1/2 equal 4P?
So the equation that we talked about on Friday and also today, A is equal to 1/4P. A is the value in front of the x squared or the y squared. Well, in this case, yeah, so whatever, so A is the value in front of the y squared or in front of the x squared. So here the A value is 1/8, here the value is 1/2. So you always set that equal to 1/4P. Better? Okay. So we've got P is 1/2. So what that means is from the, yes, 1/4P.
Can't we find the matrix that matters?
So I have 1/2 is equal to 1/4P. And what I do is I cross multiply. 4P times 1 is 4P. And 1 times 2 is 2. I divide by 4, and I get P is 1/2. We good? Okay, so now we're going to use that value to find the focus point. I move 1/2 of a unit in the direction of opening, and that's my focus. Notice how I haven't looked at all my notes on the front side. I just plot it, and then I name it. What is that location? 1/2, 0.
Yeah.
Then I move 1/2 a unit in the other direction. And I draw a line that's perpendicular to the axis of symmetry. That is called my directrix. It is a vertical line. Is that going to be x equals or y equals? X equals. And that is a -1/2. The length of the lattice rectum is the absolute value of 4 times 1/2. 2. So that means that the parabola is spread 2 units apart through the focus. So how many units would I go in each direction to get a total of 2? 1 unit in each direction. So I'm going to go 1 unit up from the focus and 1 unit down from the focus, and I will draw my segment And then I'll draw my parabola. And we are going to have Jordan determine, is this a perfect parabola or not? Jordan, you tell me when to stop with my pen, the point that you want me to choose, okay? You're just telling me when to, I got to pick a point on the parabola. You tell me which point you want. Yep. Right there? Okay. So we're going to take that spot, and the distance from the green dot to the blue dot should be exactly the same as the distance from the green dot to the blue line. What do you think? Jordan, you get to be the judge. I'll put them side by side. 9.9, not bad. Kind of on a roll. I mean, you know, be interesting if we chose a different point, huh? Be interesting if we chose a different spot. Like, what if we chose up here? Would I be just as accurate? Got that green dot. We've got this black one right there. I'll take the green and I'll flip it, and we'll see.
What happened?
So not she gave me, okay, I got an 8, but you know, so it does matter where you pick. Now to be fair, you picked that spot first, so, but you know, all right, thank you. All right, we try the next one. Okay, how about 4x squared plus 7y is equal to 0? Talk to your peer, decide, is this up, down, right, or left? Ready, set, go. Okay, I heard some people say it. This is a downward parabola. You solve and you get an x squared. Y is equal to x squared. The negative 4/7 indicates that it's going to go down. So I'll list off the important characteristics. I'm just going to move this over a little bit. Whoop, don't want to move you. There you go. So direction, vertex, axis of symmetry, focus, directrix, and the length of the lattice rectum. You already determined it goes down. Vertex, location. Zero, zero. Make a 3x3 graph. 1, 2, 3. 1, 2, 3. Yeah. 50. It's going to cool off tonight, so make sure you're dressed in layers. Jordan, who do you want to judge me this time? You get to pick the next person. All right, Paige will judge me. I'm going to plot my vertex at 0, 0. Axis of symmetry is going to divide it in half. It will be a vertical line right down the middle. I call that x is equal to 0. In order to find the focus, the directrix, and the length of the lattice rectum, what do I need to determine? P. So A, or negative 4/7, is equal to 1/4P. I cross multiply, I get negative 16P is equal to positive 7. Or P is equal to negative 7/16. That's a little bit awkward of a number. Negative 7/16. We're used to using that when we're like working on a car. Like that's like a wrench size, right? But here it's happens to be our p-value. It's approximately a half of a unit. Would you agree? About a half. So I'm going to go about a half a unit down. And that coordinate will be for my focus. That would be 0 and negative 7/16. And then I go just short of a half a unit up, and that is where I draw my directrix through. That is a horizontal line with an equation of y is equal to, and that is positive 7/16. The length of the lattice rectum is the absolute value of 4 times p. So I'll write it as 4 over 1. So on the top, I get 28. And on the bottom, I get 16. Those are both divisible by 4. So I get 7 over 8. All right, 7 over 4, excuse me. So 7/4 is the length of my lattice rectum. 7/4. That's approximately what value? 1.75. 1.75. So just short of 2, right? So I need to figure out how much to go in each direction. So if you take 7/4 and divide it into 2 parts or multiply it by a half, we get 7/8. I'm going to move 7/8 of a unit in each direction from the focus. Got that. Got that. I'm going to use that to draw my shape. And Paige is up. Ready, Paige? You pick a spot on my parabola. You tell me when to stop. Right there. Okay. So I'm going to check to see this dimension against that dimension.
Whoa, that is not it's not straight.
Score me out of 10. Come on. 11. Whoa! Mic drop. Boom. Not too bad. Looks like a perfect parabola.
No.
Yeah, I got a game. Just admit it.
Nope. No game.
Whatever. I do too. Wish you were me. All right, 12x plus 12 is equal to y minus 2, quantity squared. I'm changing the problem. It doesn't work very well if there's a 1 there. So we're just going to get rid of that. Talk to your peer. Does it open up, down, right, or left? Go. Talk. Okay, what do you think? It does open to the right. So the first indication is that the y is being squared. Because the y is being squared, we know that it's horizontal. So we know it's horizontal, and then we just solve for x. So 12x is equal to y minus 2 quantity squared minus 12. So I just subtract that 12 over to the other side. Now what do I need to do to solve for x? And as you divide by 12, you divide everything by 12, and you get x is equal to y minus 2 quantity squared over 12. I'm going to rewrite that. Instead of divided by 12, I'm going to write it as 1 over 12 times y minus 2 quantity squared, and then a minus 1. So dividing by 12 is the same as multiplying by 1/12. You can now determine the vertex. What is the vertex? We talked about this earlier. Have a glance here. Notice how the y is being paired here, right? So that means the y value is positive 2 and the x value is negative 1. So be careful if it's going horizontally. Those x and y values change spots. Now I'm going to give you a key about how to address the size of your graph. So before I plot this vertex, I want to get an idea of how many tick marks I should have on my graph. So the first thing I'm going to do is I'm going to identify P. And I have A, or 1 over 12, is equal to 1 over 4P. What is P? P is 3, so says the silent girl. Thank you. So just know that if P is 3, that means the length of the lattice rectum is 12 units. That's significant. I mean, that means you'd be moving 6 units in each direction, right? So if I'm going to move 6 units in each direction, then what I would like to have in this scenario is I would like to, go all the way up to like 10. You know what I mean? Make sure I have room. So I'm going to make a graph tick mark every 2, and I'm going to go up to 10. So 2, 4, 6, 8, 10. So notice I've done things a little bit out of order because I don't know exactly where I should plot them. I'm going to plot the -1, +2. So back 1 and up 2. And I'm going to draw my axis of symmetry. Axis of symmetry, is it going to be horizontal or vertical? Horizontal because it opens horizontally. We thank you for taking the risk. Is that equation going to be an x equals or y equals? Definitely a y equals, and so it's y equals the y value of your vertex, which is +2. In order to identify the focus, we need to know P. We've already found that P is equal to 3. So what do I do now? 3 units, yeah. So 1, 2, 3. Remember, each tick mark is 2. So that location is 2, 2. And I'll move 3 units the other direction. I don't really like, when I draw to the side, I kind of get slanted here. Paige, you get to pick the next person that's going to grade me. So the directrix is x equals -4. And then the length of the lattice rectum is 12. So that means I move 6 units in each direction from this focus. So 2, 4, 6. 2, 4, 6. Paige, who's scoring me? Phoebes? You gonna be mean to me? There's no mean. You're objective. You're just saying. You're just calling it like you see it. You get to choose where you want me to pick my point. You want me to pick at the top or bottom? Top. Can you tell me when to stop? Oh wow, she did that. Oh man, holy cow! All right, so we're gonna check this segment here, and we're gonna check it against this segment here. What do you think? Eight 8.5. Okay, I'll take it. I'll take it. I'll admit, not my finest work. I wonder if I veered off too far with the directrix up here, and that's why it went a little bit long. But hey, I tried. I'm not ashamed of my work. I'll put it out there. I feel like if you average all mine together over the past few days, I feel like I'm at about a 9, I think. The 3? I think that we should be able to get rid of the lowest score and the highest score. Well, somebody gave me an 11 today, so. Okay. That's funny business right there. All right. So there you go. You have 6 problems.